Hello everybody, it's Mrs. Pound and we are studying Chapter 10, Chemical Reactions and Equations from BJU Chemistry's 5th edition. Today we're going to stay in Section 10.1 and we're going to learn how to balance chemical equations. So our objectives today are to explain the process for balancing a chemical equation, write a balanced chemical equation for a chemical reaction when given its word equation, and describe the limitations of chemical equations for modeling chemical reactions. So the first thing we have to talk about is the fact that matter cannot be created or destroyed according to the law of conservation of matter. That's something we have talked about before and you've learned in other science classes. Because of this, we must balance chemical equations because according to the law of conservation of matter, atoms that go into a reaction must come out. And as a model for a chemical reaction, we have to obey the laws of conservation of matter. And also, according to the law of conservation of matter, the atoms that go into a reaction will remain, but they will be rearranged to form different compounds. So even though we get something new out, we still have the same matter that went in, it's just in different combinations. So a checklist for balancing chemical equations. So you will be given a chemical reaction in word form, such as nitrogen monoxide plus oxygen yields nitrogen dioxide. The first step is to write this in formulas. So here's the equation. You don't have to rewrite this because it's at the top. Only from this point forward, write those things that are in blue if it's repeated. So we know that nitrogen monoxide is NO. So oxygen. Oh yeah, that's a diatomic. So we have to write it as O2. And then nitrogen dioxide, remember, is 1 nitrogen and 2 oxygen. So that's written as NO2. So now we have our formula. Next, we ask the question, is the equation balanced? So we look at that equation that we just wrote and we asked, is it balanced? So let's first look at the nitrogens. On the left side we have 1 nitrogen and on the right side of the arrow we also have 1 nitrogen. So that looks good. However, when we look at the oxygens, on the left side we have 3 oxygens and on the right side we have 4 oxygens. So we know that we have to balance this equation. Step number 3 is we adjust coefficients only to get equal numbers of atoms on both sides. We do not touch the subscripts. It is usually best to begin with the most complicated molecule. So when we look at our equation, and do recopy it because we're going to be putting numbers in front, and leave enough space in front of each formula to write numbers. So we have our formula and it looks like this is the most complicated. So we're going to start here and we see that we have 2 oxygens over here but 3 over here. So the best thing to do is we're going to put a number 2 in front of our nitrogen, or our nitrogen dioxide. So just put a 2 in front of there. And when we do this, we see that we now have 2 nitrogens. So we need 2 nitrogens over here. So we're going to put a 2 in front of nitrogen monoxide. So we put a 2 in front of that, and then we're going to recheck and see what we have on each side. So we have 2 nitrogens on the left, 2 nitrogens on the right. 2 times 1 is 2 oxygens here and 2 oxygens here for a total of 4 on the left, and then 2 times 2 is 4 oxygens on the right. So we have a balanced equation because the 2 nitrogens here, 2 nitrogens there, 4 oxygens over here, 4 oxygens on the right. Number 4 is, are the coefficients whole numbers in the simplest ratio? If not, divide by the greatest common factor. What if, and this is our example here, what if when we balance this equation we had come up with 4NO plus 2O2 yields 4NO2. We can see here that all of these can be divided by 2. So we're going to divide all of those by 2. Do write out this whole thing. And when we do that, we get the equation 2NO plus O2 yields 2NO2. And we have the equation that we had before. Sometimes this will happen, so I just want to make you aware of it, and that you just divide everything by the same factor to get it to simplest form, just like ratios or fractions in math. Now, we'll be doing more examples of those in class. That's just the basic steps. So, the final thing I want to talk about is that balanced chemical equations cannot indicate a few things. They cannot indicate whether a reaction will actually take place. Even though we can write all kinds of reactions down on a piece of paper, it doesn't mean that they will actually happen in real life. If the reaction takes place, whether it will continue to completion. So it might take place, but that doesn't mean that all of the products will, or all of the reactants will end up being all of those products. Okay, it may not happen completely. It might happen a little bit, but not completely go to completion. Also, it cannot tell whether a reaction occurs in one step or several, so it may actually take several steps for that reaction to occur. So our objectives today were to explain the process for balancing a chemical equation, write a balanced chemical equation for a chemical reaction when given its word equation, and describe the limitations of chemical equations for modeling chemical reactions. So don't forget your 5 questions in your notes, and I will be back with another video for this chapter.